We use these things every single day, but have you ever just stopped and wondered what is really going on inside that box? We're about to pull back the curtain and, really demystify the magic behind the machine. We're going to explore how a computer actually works from the inside out. I mean, think about it. It seems so simple, right? You press the A key and boom, A pops up on your screen. But that one single action kicks off this lightning fast chain reaction. And that's exactly the mystery we're going to solve together right now.
Okay, so when you strip everything else away, a computer's job is actually super simple. It really only does three things. It takes something in, that's the input. It thinks about it, that's the process. And then it gives you something back, the output. Seriously, everything your computer does, from playing a game to sending an email, it all boils down to this one simple but really powerful cycle.
So let's just walk through it real quick. First, you do something, you provide some data, like clicking a mouse or typing a word. Then, the computer takes that and thinks about it, following a set of instructions. And finally, it spits out a result, maybe a letter on the screen or your favorite app opening up. It sounds easy, but all the real magic, it's all happening in step two. Exactly. This is where it gets really, really cool. That process box is a total black box to most of us, right? I mean, what kind of thinking is actually going on in there? How does a machine made of metal and silicon process anything at all? Well, inside that process box, we find the brain of the entire operation. This one little piece is the nerve center, the master controller that handles absolutely everything. This brain has a name, the Central Processing Unit, or as you've probably heard, the CPU. But here's the thing, the CPU isn't just one big blob. Think of it more like a brain with two very specialized halves that work together, the Arithmetic Logic Unit, or ALU, and the Control Unit, the CU. This really breaks it down perfectly. The ALU is like the math whiz part of the brain. It just crunches all the numbers, does all the addition, subtraction, all the logical stuff. The CU, on the other hand, is the director. It doesn't do any of the math itself, but it's the boss, telling everyone else what to do and when to do it. It basically runs the whole show. And this is it. If you remember one thing, remember this little phrase. It sums up the entire CPU perfectly. The ALU calculates, and the CU controls. One does the math, the other gives the orders. Simple as that. Okay, but what good is a brain if it can't remember anything, right? It needs a place to hold the information it's working on right now, and it needs a place to store stuff for later. Well, a computer is exactly the same. It needs memory to get the job done. And the way a computer's memory works is a perfect analogy for our own brains. It has primary memory, which is like your short-term memory. It's incredibly fast and holds whatever the CPU is actively thinking about. And then it has secondary memory, which is like your long-term memory. It's for permanent storage, holding onto your files and programs even when you turn the power off. Now, you've probably heard of RAM, right? Random access memory. That's the most common kind of primary or short-term memory. The best way to think about it is like the CPU's desk. It's a temporary workspace. And the more RAM you have, the bigger the desk, which means the more things the computer can juggle at once without getting all slow and confused. And for that long-term permanent memory, you've got all the stuff you're super familiar with. The hard drive, a USB pen drive. These are like the computer's filing cabinets. It's where you save all your photos, your documents, your apps, so you can come back to them later. So we've met all the key players, right? We have the input devices like our keyboard. We have the CPU acting as the brain, and we have our short-term desk and our long-term filing cabinet. Now let's watch them all come together and do their thing. And here is that whole dance in action. It all starts with you hitting a key. That's the input. That single keystroke is instantly put on the CPU's desk, the RAM. Then the director, the control unit, grabs that data and hands it over to the math whiz, the ALU, for processing. And then the control unit sends the final result, say the character A, right to your screen. Input, store, process, output. And just remember, this entire process gets kicked off by an input device. These are just the tools that we use to talk to the machine. Your keyboard, your mouse, your microphone. You could almost think of them as the computer's senses, feeding it data from our world. And the cycle always ends with the output. This is how the computer talks back to us. The monitor shows us what's happening, a printer gives us a hard copy, speakers give us sound. It's the grand finale of this super fast conversation. Now, here's the part that just blows my mind. That whole sequence we just walked through, input, process, output, it's not happening in slow motion. It's happening at a speed that is almost impossible for us to even comprehend. A modern CPU can run through this entire cycle billions of times every single second. It's insane. So that next time you move your mouse or type a sentence, just remember that incredible high-speed dance happening behind the screen. You are the one kicking off billions of these cycles. You're the conductor. So now that you know how it works, what are you going to command it to do next?